Jambo, and welcome again to my series here. And the series is on organic chemistry qualitative analysis. This comes immediately after my discussion on inorganic qualitative analysis. Now, I must start by saying that organic qualitative analysis, basically, we are trying to analyze organic substances. We are trying to organize organic substances. And I believe that we've been able to look at maybe the few organic substances or the homologous series that maybe we talk about in organic chemistry, both maybe 1 and 2 for high schools in Kenya and East Africa. We talk about the unsaturated organic compounds. I think mostly maybe we were able to look at maybe things like the hydrocarbons, but this one may not necessarily be hydrocarbons. So we have the unsaturated, which are mainly represented by a double and a triple bond. Then we also talked about others like the ROH, which are alcohols or alkanols. And we also did talk about the alkanoic acids, which we normally present with RCOOH, RCOH, these are alkanoic acids. I would say that it's important to have the chemical properties and even the physical properties of each and every one of them to be able to handle this question satisfactorily. However, I want to encourage that it is one of the easiest areas in handling. Number one, because the practical itself is limited to a few reagents. And I think it will be important if you are only able to have the mastery of these reagents, then you can easily be able to tackle a question on organic qualitative analysis. As I said, maybe in the previous series, I did mention that every time you go to your lab, it would be important, first of all, to ask yourself, am I dealing with organic chemistry, qualitative analysis, or inorganic? This is very important. So that you put your mind that now here, I'm looking at the functional group, the ROH, the LCCOH, the double and triple. You also maybe think, am I analyzing a cation? This is very, very much important. Now, and basically what we look for here, you try to look at the reagents that are there, the bromine water, the acidified potassium dichromate, the acidified potassium manganese 7, the issue of burning, and all this. This one can tell you that I'm actually dealing with organic chemistry qualitative analysis. Without wasting time, I want us to go through a question. And here we'll be trying to predict, maybe you can try to think about the observations that are expected and maybe how we can make inferences given the few or given the observation. So I'm going to share my screen here, and it will help us maybe to go through our, yes, and there it is. This was a question 2. I did a question 1 a while ago. Now, you're provided with solid Q, carry out the test below and record your observation and inference in the spaces provided. Now, in the first case here, you're scooping, you're required, you scoop half of solid G using a spatula and put it in a non-luminous film. Now, every time an examiner asks you to put a solid or to burn a solid, what you'll be trying to look at mainly is the frame. The frame produced. And mostly we do expect a blue flame. This is for the saturated organic compounds. For example, the alkanes, the alkanols also can burn with this. Now, at the same time, we can also have a yellow sooty frame. A yellow sooty frame. Now, yellow sooty frame mostly, this one here will be, the substances that produces a yellow sooty frame are normally the unsaturated and the long chain organic compound. Any organic compound with a long chain of carbons may burn with a yellow sooty frame. Now let's have a look at maybe a probable observation that you can have here, and then we see what you're talking about. Now look at that. Yes. Now, as you can see from this, based on maybe one of the songs that I analyzed, I would say, as I have mentioned here, it is important to observe more than just a frame. Look at this, for example, a solid melting into a colorless liquid here, we may assume this, melting into colorless liquid, then burning with the aerosol frame, and then you just try to see, does anything remain? You know, a black residue remains. Now, let's have a look at maybe such an observation. You made such an observation. What should be the inference? What should be the inference? And here we go here. Look at this, what we're talking about. This is what happens, or this is how we're going to put it, that the triple and double. Now, these ones here, we refer to them as unsaturated. Now, as unsaturated carbon compounds, basically, will have a high carbon hydrogen ratio. And therefore, this one will make them burn with the aerosol frame. Now, there is also something that maybe we also mark here. This is a long chain organic compound. Long chain organic compound. In most of the cases, when maybe we are marking this one here, we may not necessarily this one. Sometimes, mostly we're going to put this too, but it's not a problem if you include the long chain organic compound. And actually, I've noted that in most of the cases, some of the students, every time they're going to see a aerosol frame, sometimes they will confirm. They'll begin in their mind. They're going to put, or they're going to put in their mind that maybe the double, triple is there, but this one is not a confirmatory test. I want to say that this is not a confirmatory test. When we are burning, it is not always a confirmatory test of unsaturation. That's what we are talking about. So basically, this is the way you do it, and the reason is each of this, the double bond, the triple, the long chain organic compound there, we expect them because of high carbons, a high number of carbons, or the ratio of carbon to hydrogen, they're going to burn the aerosol frame. Now, so let's move further to the other one. We are going to add water. Now, the addition of water in organic chemistry, maybe unlike the inorganic. You know, in organic, we are looking for maybe is that salt or is that substance soluble or not. But as far as the organic chemistry is concerned, we are looking for whether the substance is polar or not. Though it's not a confirmatory thing, I would say. For example, in organic compounds, things like, for example, the ROH, especially the ROH, the LCOH, the alkanoic acids, and the alkanols for ROH, and organic salts. They are polar. They are normally polar. You know, they are normally polar. Therefore, at the back of your mind, maybe you can be able to tell maybe there is a likelihood of this. However, this is not the time to comment about them. So here, what do you look for here? You are looking for whether the substance will dissolve or not. And number two, there is also a likelihood of it not dissolving. If it doesn't dissolve automatically, it will be non-polar. If it dissolves, it will be polar. Let's look at maybe a likely observation that we can make from here and see what you're talking about. Now, this one here, solid dissolving, forming a colorless solution, and automatically this one implies that it implies that my solid is actually polar. My solid is actually polar. Let's have a look at that. Now, then, let's move to the next one. So far, what we can be able to say here that I'm either having it is either unsaturated compound, it is a long chain, and then number two, we can say the substance is polar. So far, we can have those two comments about the solid. Now, let me mention about acidified potassium dichromate 6. Now, this acidified potassium dichromate 6 is orange in color, I would say that. And something special about this potassium dichromate 6, we are going to use it to confirm the ROH, which is actually alkanols. I repeat it again because in this organic chemistry question, in organic chemistry, I want to say there are two reagents. There are two reagents that we can actually be able to confirm some compounds or some homologous series. And we have two. We have potassium dichromate 6, which confirms the ROH. We also have bromine water, which confirms the presence of unsaturation, that the triple and the double. Now, and therefore, with this one here, every time you're adding potassium dichromate, you are looking for ROH. And therefore, the observation is either the ROH is absent or it is present. Now, this is what we expect here. The orange potassium dichromate 6 is expected to change from orange to green. Remember, this one is an oxidizing agent, and as it oxidizes, the dichromate ions, which are orange, they are normally reduced to green chromium 3 ions. That's what we're talking about. Let's have a look at maybe a likely observation that we can get from here, and we see what we're talking about. Now, this is the thing here. Look at that. Orange acidified potassium dichromate 6 retains its color. I want to say this, that when you're commenting about this, you must mention the color. You must mention the color of the reagents. And this one is also applies for potassium manganese 7. You must be able to mention the color so that you're able to get the full mark. So with this one here, automatically we're looking for ROH. It is either present or absent, and maybe you can be able to tell by now that from what we've just observed, that indeed the ROH is absent. Look at that. The ROH is absent. That's what we're talking about. Now, very fast, we get to the other. The other one we are using acidified potassium manganese 7. I want to say that this one here does not really confirm, any homologous group. And I want to say that potassium manganese 7 here, one, it is purple. And this potassium manganese 7 can be decolorized. It can be decolorized by 3 functional groups. We have the ROH, and this one we've already confirmed it is absent. Number 2, by the double on the answer. Let me call them unsaturated. Mostly when we are dealing with unsaturation, we don't differentiate between the two. Therefore, the unsaturated organic compound, there's a double bond and a triple bond. That's a thing. And therefore, again, this one here cannot be able to confirm. They cannot be able to confirm either, but it can help us in one or the other. So what happens here is, again, during this reaction, again, it's an oxidizing agent. And what we expect during this reaction is that the manganese ions, which are purple, they are reduced to manganese 2 ions, which are colorless. That's what we are actually talking about. Now, let's maybe give an example of an observation that we can actually get, and then we see what we are talking about. Now, look at that one there. Purple acidified potassium manganese 7 is decolorized. It is decolorized. It is decolorized, or change to colorless. Change to colorless, or it is decolorized. Now, in this particular case here, actually, if we use potassium manganese 7 earlier, before confirming that ROH is absent, then you would expect me maybe I would mention the 3 of them. The 3 of them are present, that the double, the triple, the ROH are actually present. But the fact that we have already confirmed that ROH is absent, now here, this is the way we do it. We are going to do it this way. So I'm going to have the double and the triple. Look at that. The double and the triple are present. Please don't include ROH here. The fact that you have confirmed that the ROH is absent using the potassium dichromate, That's basically what we are talking about. And maybe in the other procedure here, I'm going to use bromine water. Now, this bromine water, as I said here, this is a substance that can actually, or we can use it to confirm the unsaturated organic compound, the double and the triple. And actually, if something like bromine water is brought even earlier, if it is brought earlier, and you realize that maybe it is absent, and then maybe later on you use potassium manganese 7 and you realize it is decolorized, then this one could also confirm that ROH is present, because the bromine water can be used to confirm either the presence or the absence of the double and the triple bond. That is the unsaturation. That's what we're talking about. Now, in this particular case here, bromine water is normally yellow. We mark yellow, and the yellow, and as during this reaction here, that bromine water is actually, or it changes color from yellow to colorless. That's what we are talking about. So I'm going to have this one here. Let's look at maybe an example of an expectation that we can have here. Let's have it. So I'm going to have yellow bromine water is decolorized. Yellow bromine water is decolorized. And I said here, every time you're using bromine water, you are only talking about the unsaturated organic compounds. It is either double bond or triple bond. It is either present or absent. And the fact that maybe the yellow bromine water has been decolorized, then we can go ahead and we can actually confirm. We can confirm that the double and the triple, in other words, the unsaturated organic is unsaturated. That's what we're talking about. And finally, maybe not finally, we have sodium hydrogen carbonate. I want you to realize here, my learners, I want that in Form 1 you mentioned about the properties of acids, and acids can react with carbonates. They can react with hydrogen carbonates. The sodium hydrogen carbonate here, it can only react with acids. It's important to mention that. And therefore, every time we are using sodium hydrogen carbonate, we are actually testing for the alcoH, the functional group of alkanoic acids. And with sodium hydrogen carbonate, of course, when you put it in an acid, remember this is an acid. Alkanoic acids have hydrogen ions, just like any other acid. And therefore, when you put it, your hydrogen carbonate, you expect effervescence due to production of carbon dioxide. Now, therefore, it is either fizzing occurs or does not occur. Now, let's look at maybe a scenario here, and we see what we're talking about. Now, scenario here is that, look at this. Our scenario here is that the fizzing occurs. The fizzing occurs. Now, if the fizzing will occur, then what are we saying? If the fizzing occurs, what are we talking about? Fizzing occurs here, then we can say that alcoH is present. But I would say here that we must also include hydrogen ions. Sometimes it's not necessarily the alcoH. We can have substances where maybe substances may hydrolyze. They may hydrolyze in water and maybe form other acids. It may not necessarily be an organic acid, but they can hydrolyze in water and form an acid. Therefore, just include hydrogen ions every time you have the alcoH. And then maybe the last one here, determining the pH of G. Now, this procedure, sometimes you may be required to write a procedure, sometimes you'll be given a procedure. The procedure can be as simple as this. Deeper universal indicator paper in the fourth portion. Use a pH chart to determine the pH. Now, in most of the cases, there are some schools that will use a universal indicator solution. You can just add 2 to 3 drops of the universal indicator, and then you can use a pH chart. Always, this is very important. Use a pH chart to determine the pH. Now, I would like to say here that many people assume that organic acids have a pH of maybe about 4, but this is not always the case. So therefore, I would say trust your results. Trust your results. It may not be the case. Sometimes you can have an organic acid that is actually a strong acid. Therefore, let's trust our results and we'll be able to get there. Now, let's look at this here. So with the pH, maybe let's look at maybe a likely observation that you can have. And we see pH 3. This is the observation that you make. I've seen some maybe students trying to identify a color, a yellow or a red or indigo. I mean, here we don't expect you to mention any color. Just try to match your solution after adding the indicator with the pH chart. Once you match them, just write the pH 3 or the pH number. This pH number will be my inference. And then finally here, the inference from this, we know very well that what universal indicators do, they are made to measure or to tell us the strength of the acid. And therefore, here, you've got to have an idea of the strength. I mean, the strength of an acid. Actually, we normally say that for an acid between pH 0 to 3, that's strong acid. From 4 to 6 point, that one is a weak acid. And therefore, what are we expected to put across here? Number one, we already can be able to tell the strength of the acid, or maybe the pH, the strength of the acid. And therefore, how we are going to put it? Yes, look at that. Strongly acidic. Strongly acidic. We are going to have it that way, strongly acidic. And this is the way. Please don't write strong acid put it strongly acidic. Strongly acidic. Now that's the thing here. We can deduce that one from the pH scale. That one is strongly acidic. And then number 2 here, the fact that it is an acid, then we can also be good to tell that indeed hydrogen ions or RCOH are present. And basically that's what we are talking about. In other words, what was dealing with, the compound that I was dealing with, one, it was an acid. It could have been an organic acid. It could have been an organic acid, you know. Now, this organic acid here was unsaturated. Please, we can have all these functions. We can have 2 functional groups in a given compound. It can be an acid that is unsaturated. And they are subscribed and like, and God will bless you. Thank you very much, and I wish you well. Asanteni. Thank you.